Off the coast of Indonesia, the wind blowing off the sea is hot and dry. The grass on the hills of Komodo and Rinca turns the color of old bone under the baking sun. In this dry savanna and monsoon forest, water is incredibly scarce. Finding large prey is even harder. Yet, moving through this narrow world is the largest lizard on Earth. A full-grown male can carry the weight of an adult human, stretching close to 3 meters long. They patrol these scrublands with absolute patience. There is no other animal on these islands that hunts them. To survive in such a punishing, isolated place, this apex predator evolved a highly specific method for killing, a method we spent half a century completely misunderstanding. Biologists struggled to explain how a predator of this scale sustains itself on islands where large prey is so scarce. In 1981, an American biologist named Walter Offenberg offered an answer. After observing the dragons, he proposed they deliberately cultivated a foul brew of deadly bacteria in their mouths, using it as a biological weapon. According to this theory, the dragon delivers a quick bite. The wounded prey tears itself free, escapes, and then, days later, slowly succumbs to a rotting infection. That grim explanation was written into textbooks and repeated in wildlife documentaries for 50 years. It was accepted as scientific fact, despite no one ever checking the inside of the animal's mouth to verify it. A hunting dragon does not chase its food. It chooses a place where wild boar and deer pass, and it waits in the shade, motionless, for hours. The only movement is the animal flicking its forked tongue. It catches scent particles from the air and pulls them to a sensory organ on the roof of its mouth, detecting prey from incredible distances. When a deer finally wanders into range, picking its way through the brush, the dragon remains entirely still, letting the animal unknowingly close the distance. Then, all that waiting ends in a sudden, explosive physical lunge. If the jaws make contact, the deer is completely doomed. Death arrives through a precise chemical intervention, long before a bacterial infection could take hold. When venom researcher Brian Fry and his colleagues finally swabbed the mouths of Komodo dragons, they found ordinary, unremarkable flora. The bacteria levels were actually lower than what you would find in a captive lion. So in 2009, Fry's team put a dragon under an MRI machine to look beneath the tissue of the lower jaw. Hidden there was a complex, multi-chambered venom gland system with ducts opening right between the teeth. Once in the bloodstream, the venom attacks the circulatory system, rapidly dilating blood vessels and plunging blood pressure into systemic shock. Simultaneously, an anti-clotting compound ensures the wound bleeds freely. Red blood cells flow out, unable to aggregate and seal the gap. The dragon does not need brute strength to crush its prey or hold on until it suffocates. It only needs to open a single wound and let its refined chemistry drain the victim from the inside. The physical bite itself is engineered around that goal. The animal clamps down with surprisingly modest jaw force, then pulls back with enormous neck muscles to rake the flesh open. And the tools making that gash hold their own secrets. In 2024, researchers at King's College London examined the dragon's teeth and noticed a faint orange tint along the very tips and edges. That color comes from an intensely concentrated layer of iron. The mineral hardens the serrations, acting as built-in armor to keep every tooth sharp through a lifetime of hitting bone and tearing muscle. The bite functions as an iron-laced scalpel, opening the flesh to create the maximum surface area for venom to flood the system. Paleontologists describe tightly curved, sharply serrated blades like these as xiphidont teeth. If you look closely at these fossils, you can see that the xiphidont design of the dragon is almost identical to the teeth of the great theropods, the dinosaur lineage that includes Tyrannosaurus rex. Watching a Komodo drag down a deer is watching a biomechanical hunting style that has survived continuously since the age of the dinosaurs. This leaves one glaring question. If the venom works so fast, why did Walter Offenberg document prey escaping, only to slowly die of infection over several days? When a dragon hunts the native deer and wild boar it evolved alongside, the kill is clean. The venom does its work, and the prey bleeds out within half an hour. There is no time for an infection to take hold. Offenberg's observations were heavily based on water buffalo. Humans brought buffalo to the islands, and their massive bodies are simply too large for a single dose of venom to drop them quickly. A wounded buffalo, seeking relief, will wade into a stagnant pool like this one, fouled with mud and its own waste. It stands in that filth for days with an open injury, allowing waterborne bacteria to rapidly infect the wound. The myth of the filthy mouth was a misread of a human-created ecological anomaly. The dragon provided the wound, but the swamp provided the rot. The very compounds that make the dragon so lethal, the molecules that drop blood pressure and thin the blood, are exactly the mechanisms modern cardiologists seek to control. Researchers are now using the dragon's specialized chemistry as a molecular library, studying compounds shaped by evolution to develop life-saving human medications. Yet the animal providing these potential cures begins its life highly vulnerable. Hatchling komodos are actively hunted by the adults of their own kind. To survive, a newborn dragon climbs. They spend their early years up in the canopy, hiding out of reach of the larger adults on the ground. They descend to the earth only when they grow too heavy for the branches. The patient, unbothered killer waiting in the shade earned that confidence only after surviving a terrified youth. Today, this ancient survivor exists in only a few square kilometers of scrubland. Fewer than 3,500 remain in the wild, cementing their status as an endangered species. Shedding the 50-year myth of the filthy scavenger did not diminish the Komodo dragon. It revealed an intricate, iron-toothed chemical marvel that persists long after the fairy tales have faded.